Evidence of relation between Earth impact craters and extinction level events have now been found. The opinion of scientists is divided about the relation between mass extinctions and impact craters caused by asteroid and comet showers on Earth. Now, two researchers, Michael Rampino, a New York University geologist, and Ken Caldeira, scientist in the Carnegie Institute, Department of Global Ecology, concluded through their observations that the age of impact craters is linked to mass extinctions of life on Earth, including the demise of the dinosaurs 66 million years ago. They have observed a cyclical pattern in which impacts and extinction events have taken place every 26 million years. So they have found that this pattern takes place every 26 million years. Why is that? To support their theory, the two scientists performed time series analysis of impacts and extinctions and came to the conclusion that the correlation between the formation of the impacts and extinction events over the past 260 million years suggests a striking cause and effect relationship. Now, 260 million years ago, we had what we know as the Permian-Triassic extinction event, and we'll go into that in another video. But why this 26 million year cycle? This is from Science Daily, from Royal Astronomical Society. For more than 30 years, scientists argued about a controversial hypothesis relating to periodic mass extinctions and impact craters caused by comet and asteroid showers. Now these scientists conclude the mass extinctions occurring over the past 260 million years were likely caused by comet and asteroid showers. Mass extinctions occurred over the past 260 million years were likely caused by comet and asteroid showers, they concluded. For more than 30 years, they argued about a controversial hypothesis relating to periodic mass extinctions and impact craters caused by the comet and asteroid showers on our Earth. In their MNRAS paper, Michael Rampino, New York University geologist, and Ken Caldeira, Carnegie Institute, Department of Global Ecology, offer new supporting linking the age that these craters with recurring mass extinctions of life, including the demise of dinosaurs, show a cyclical pattern over the studied period, extinction events taking place every 26 million years. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. This map shows the Clovis comet, Younger Dryas comet, about 13,000 years ago, initially thought to have been only in North America and then the Northern Hemisphere. These comet pieces, some of them 2 miles wide, have been found all across the globe. Now, the 26 million year cycles. This cycle has been linked to periodic motion of the sun and planets through the dense midplane of our galaxy. So it has to do with our solar system going through the midplane of our galaxy, they said. Scientists have theorized that gravitational perturbations of the distant OORT comet cloud that surrounds the sun lead to periodic comet showers in the inner solar system where some comets strike our Earth. That's bad news, obviously. To test her hypothesis, Rampino and Caldeira performed time series analysis of impacts and extinctions using newly available data offering more accurate age estimates. Rampino says the correlation between the formation of these impacts and extinction events over the past 260 million years, that was the Great Dying, as we know, that happened that Permian-Triassic extinction, the Great Dying, what we call. I'll do a next video on that. The extinction events over the past 260 million years is striking and suggests a cause and effect relationship, Rampino explains. Specifically, he and Caldeira found that 6 mass extinctions of life during the studied period correlate with times of enhanced impact cratering on Earth. One of the craters considered in the study is the large 180 kilometer diameter Chicxulub impact structure in the Yucatan Peninsula, which dates to the extinction of the dinosaurs 65 million years ago, the time of the great mass extinction, including the dinosaurs and a lot of other life on Earth. Moreover, they add 5 out of the 6 large impact craters of the last 260 million years on Earth correlate with mass extinction events. Rampino observes this cosmic cycle of death and destruction has without a doubt affected the history of life on our planet. So obviously this is a very important thing to keep in mind. A cyclical 26 million year impact of comets and asteroids because of the way our solar system travels through the depths of our galaxy, the Milky Way galaxy. The OORT cloud with comets out there is part of our solar system. This is a short video clip by NASA explaining where it is. This is a NASA video concerning the OORT cloud.
If you had to guess, where would you think our solar system starts and where do you think it ends? If you think our solar system starts at the sun, then you would be right. How about where it ends? Does it end at A, just past Neptune, B, at the Kuiper Belt, or C, past the OORT cloud? The answer is... If you guess C, past the OORT cloud, you're correct.
The OORT cloud is a giant cloud or collection of comets that surrounds the sun. It's huge, and all of these comets are bound to the sun gravitationally, which means they are in orbit around the sun. They're not escaping into interstellar space. So they really belong to our solar system. The limits of our solar system are really defined by the limits of the sun's gravity, and that extends basically to the edges of the OORT cloud. The solar system begins at the sun. That's the main body in the solar system gravitationally. The solar system ends where the gravitational influence of the sun stops or fades out.
I get it. So if you thought our solar system ended with our planets, you're wrong. The solar system begins with our sun and extends way beyond the planets. But how does NASA know that?
One way to tell where the solar system ends is by actually going there with a spacecraft. NASA studies the solar system through missions that go out and investigate planets, for example. Voyager was launched in the 1970s to go to Jupiter, Saturn, Uranus, and Neptune to study those planets up close and their moons. And Voyager went to the edge of the heliosphere, and it passed through a kind of a boundary into interstellar space. And that's one definition of where the solar system ends. Another way is to track the orbits of comets. And we can see that they come from these extremities of the OORT cloud that are so far away from the sun. So we get a feeling for how large the OORT cloud is by looking at the orbits of these comets.
And that's what is so exciting about science. New technologies continue to help us learn more about our vast solar system.
So let's keep in mind that these astrophysicists found that the comets that impact our Earth, comets and asteroids, have a cyclical pattern having to do with our solar system passing through the Milky Way galaxy every 26 million years, coming from the OORT cloud. Please leave your comments. Thank you for your support.